Let's go straight into the crumpled wiring of the aging brain, where some of the biggest mysteries in medicine are beginning to unravel thanks to the unexpected partnership between neuroscience and machine learning. Imagine this. Your brain is not only losing neurons with age, it's also being overrun by glial cells that have stopped being helpful and started acting like nosy, bitter neighbors. They're not dying. They're not working. They're just senescent. And now, AI is being brought in to figure out who these cellular slackers are, what they're doing, and whether politely or not so politely, showing them the door might reverse the slide into neurodegeneration. First, a refresher. Glial cells are the unsung heroes of the brain, not the flashier neurons, but the maintenance crew, traffic controllers, and general contractors. Astrocytes manage nutrients and neurotransmitters. Microglia are the immune watchdogs. Oligodendrocytes insulate nerves like electrical tape. But as we age, some glial cells start to act weird. They stop dividing. They swell up. They secrete inflammatory factors. They become senescent. And unlike neurons, which often just die when they're damaged, senescent glial cells linger. They don't clean up messes anymore. They become the mess. Here's where machine learning comes in with a literal brain scan. Because manually trying to classify senescent glial subtypes by eyeballing stained tissue samples is like trying to sort through a crowd of 10,000 retirees to find the one starting a riot. AI, however, doesn't blink. It processes high-dimensional imaging data, think single-cell transcriptomics, multiplex immunofluorescence, spatial proteomics, and starts to see patterns that humans can't. It can recognize whether a microglial cell is just normally activated or whether it's in full-on zombie mode, secreting toxic signals that break down synapses and call in more inflammation, like a cellular megaphone. And here's where things get really juicy. Those AI-driven maps of glial senescence are starting to show strong connections to diseases like Alzheimer's and Parkinson's. In Alzheimer's, for example, senescent astrocytes and microglia may not only fail to clear amyloid plaques, they may actually make the problem worse by releasing pro-inflammatory cytokines that turn the brain into a simmering stew of neurotoxicity. In Parkinson's, similar mechanisms may involve glial cells that are supposed to support dopamine neurons, but instead quietly sabotage them through oxidative stress and metabolic dysfunction. Now, imagine being able to distinguish not just senescent versus non-senescent cells, but the subtypes of senescent cells, like a classification of glial burnout. Maybe some senescent astrocytes are protective early in disease, trying to hold the line before they collapse. Others might be the ringleaders in long-term inflammation. The difference is crucial because it could inform treatment. We don't want to kill every glial cell that looks old. We want to find the toxic subtypes, the ones actively spreading damage, and target those. This is where next-gen senolytic strategies come in. Drugs or biologics that can, with surgical precision, eliminate or reprogram specific senescent cells. Think of it as cellular pest control, but only targeting the termites and leaving the bees. And AI is helping develop the wanted posters for each subtype, not just general aging markers, but detailed expression patterns, protein signatures, spatial behavior. Suddenly, we're not flying blind in the fight against brain aging. We've got blueprints. And what if we go one level further? Imagine real-time brain imaging tools trained on these AI models, allowing doctors to see where clusters of harmful glial senescence are forming long before symptoms appear. That's not science fiction. It's a plausible future with advancements in PET tracers and functional MRI data layered with AI analytics. This would shift Alzheimer's or Parkinson's treatment from damage control to proactive maintenance, catching the fire before it becomes a wildfire. So yes, the brain is aging. But maybe it doesn't have to become a haunted house of cellular ghosts. With machine learning decoding the secret lives of glial cells, we're no longer stuck wondering why some people lose their memory and others stay sharp. We're starting to see the map, and like any good map, it's showing us more than danger. It's showing us where to go next. In the end, it's a pretty hopeful vision. That maybe the secret to cognitive longevity isn't just about preserving neurons, but about managing the glial population, ensuring that your brain's support staff doesn't turn into a group of grumpy, gossiping, inflammation-spewing zombies. And with AI guiding the way, we may finally get the upper hand in one of medicine's oldest battles, outsmarting the brain's own decay.